This is problem number 23 from Hall and Knight Higher Algebra, Chapter 1 Ratios. Again, we have been given three equations in x, y and z, and we have to find the values of x, y and z. Again, we are going to use the same technique, that is the rule of cross multiplication, that we have already used in problem number 20, 21 and 22. But this time we have been given two equations which are in terms of x square, y square and z square, and one equation in terms of x, y and z. So for finding x, y and z, we cannot use equation 1 and 3 directly or equation 2 and 3 directly, because the order of x, y and z are different in equation 3 from that in 1 and 2. But we can use equation 1 and 2 together, and that will give us the relationship between x square, y square and z square instead of x, y and z. Okay, so what we will get is, from equation 1 and 2, we get x square divided by, so we have minus 2 times minus 15 is 30, minus 3 times 5 is minus 15. So minus 15 is plus 15. Is equal to y over 5 times 7 is 35, minus 3 times minus 15 is minus 45. So minus 45 is plus 45 is equal to z square over 3 times minus 3 is minus 9, minus 7 times minus 2 is minus 14, minus 14 is plus 14. So we have x square by 45 is equal to y square by 80 is equal to z square by 5. So this means we will just divide all the denominators by 5. So we get x square by 9 is equal to y square by 16 is equal to z square. Now this is very important that you notice that this is a relationship between x square, y square and z square. This is not a relationship between x, y and z. Okay, so what we get is x is equal to plus minus 3z. Okay, because if you take x square, then we get 9z square. So it can be plus 3z as well as it can be minus 3z. Similarly, y is equal to plus minus 4z. Now we can form 4 cases. Case 1 is x is equal to 3z, y is equal to 4z. This is case number 1, and we put the values of x in the equation number 3. So what we get is 3z times 5 is 5x is actually 15z, minus y is equal to 4z. So 4 times 4z is minus 16z plus 7z is equal to 6. So this gives 6z is equal to 6. Okay, from here we get 15 minus, or z is equal to 1. So for case 1, our solution is, for case 1 the solution is x is equal to 3z, y is equal to 4z, and z is equal to 1. So this is x, this is y, this is z. Okay. Now for case number 2, let us say case number 2 is, case 2 is x is equal to 3z, y is equal to minus 4z. Okay, because y can also be equal to minus 4z. So in this case, equation number, if we substitute these values in equation number 3, what we get is 15z like before, but this time minus 16z becomes plus 16z plus 7z is equal to 6. Okay, and we get 15 plus 16 is 31, 31 plus 7 is 38. So 38z is equal to 6, or z is equal to 3 by 19. So for case 2, the solutions will be 3z, which is x is equal to 3z, so this will be 9z by 19 minus 4z, so minus 12 by, sorry, this is 3z is 9 by 19. Okay, minus 12 by 19, and z is equal to 3 by 19. So this is the second solution. For case 3, case 3 will be x is equal to minus 3z, y is equal to 4z. Okay, so in this case the third equation will become minus 15z minus 16z plus 7z is equal to 6. So this is minus 31, minus 31 plus 7 is minus 24, minus 24z is equal to 6, or z is equal to minus 1 by 4. So the third solution to this is x is equal to minus 3z, so minus 3 times minus 1 by 4 is 3 by 4. Y is equal to 4z, so y is equal to minus 1, and z is equal to minus 1 by 4. So this is the third solution. And case 4 is x is equal to minus 3z, y is equal to minus 4z, and you get minus 15z plus 16z plus 7z is equal to 6, or 8z is equal to 6, or z is equal to 3 by 4, and our our fourth solution would be x is equal to minus 3z, so this will be minus 9 by 4, y is equal to minus 4z, so this will be equal to minus 3, and z is equal to 3 by 4. So we have total 4 solutions of x, y and z.